I welcome you to my channel Learn with Pharmacy. In today's video we are going to acquire detailed information on Raoults Law. Before starting video, subscribe and press notification bell for regular updates. So what is Raoults Law? The statement is, Raoults Law states that the partial vapor pressure of each volatile constituent in a solution is equal to the vapor pressure of the pure constituent multiplied by its mole fraction in the solution at given temperature. P1 is equal to P1 naught x A naught. This is the Raoults Law. In this law, P1 is partial vapor pressure of component A in solution, and P1 naught is vapor pressure of pure component A, and x1 is mole fraction of A in a solution. So, what does Dalton's law means? Statement of the law is, Dalton's law of partial pressure states that the total pressure exerted by a mixture of ideal gas may be considered as sum of the partial vapor pressure exerted by each gas. Hence, total pressure is equal to partial vapor pressure of 1 plus partial vapor pressure of 2. So, it will be P1 plus P2. Hence, Dalton law is P1 naught x1 plus P2 naught x2. Now we will see ideal and non-ideal solutions. Liquid solutions can be classified as ideal and non-ideal on the basis of certain properties. So, what is ideal solution? Ideal solution obeys the Raoults law over the entire range of concentration. Delta H mixing is equal to 0, and delta 5 mixing is equal to 0. Example of ideal solution will be solution of N-hexane and N-heptane and solution of bromoethane or chloroethane. It can be summarized as, if a solution formed by mixing the two components A and B, in which intermolecular force of attraction between A and B, that is A minus B, is nearly equal to intermolecular force of attraction between pure components A minus A and B minus B, then no heat would be evolved or absorbed in forming the solution. Also, volume of the solution will be equal to the total volume of the individual component taken to form the solution. For non-ideal solution does not obey the Raoults law over the entire range of concentration. Here, delta H mixing is not equal to 0, and delta 5 mixing is also not equal to 0. Example, chloroform and acetone solution is best example. It can be summarized as, if a solution formed by mixing the two components A and B, in which intermolecular force of attraction between A and B, A minus B, is not equal to intermolecular force of attraction between pure components A minus A and B minus B. This new interaction, A minus B, is either less than or more than the interaction of the pure components A minus A and B minus B. This leads to the positive or negative deviations from Raoults law. This law is opposite of ideal solution. Positive derivation from Raoults law will be, the vapor pressure of solution formed by mixing two components is higher than predicted from Raoults law. The new intermolecular interactions formed by mixing the component A and B, A minus B, are weaker than the intermolecular interactions of pure component A minus A and A minus B. Example, mixture of ethanol and acetone, solution of carbon disulfide and acetone. The below graph represents the positive deviation of Raoults law. Negative deviation from Raoults law will be, the vapor pressure of solution formed by mixing two components is lower than predicted from Raoults law. The new intermolecular interactions formed by mixing the component A and B, A minus B, are stronger than the intermolecular interactions of pure component A minus A and A minus B. Example, solution of phenol and aniline, chloroform and acetone. Below graph representing the negative deviation of Raoults law. Here is the end our topic. Like, subscribe, and press the notification bell for latest update. Don't forget to comment how interesting video was.